can you solve this geometry challenge? Here's the question. Given this quadrilateral, let's draw a semicircle inside of it, wherein the radius of the semicircle is 6 units, and the length of this segment is x, the length of this segment is y, and the length of this segment that is tangent to our semicircle is 13. But the question is, what is the length of the segment x and segment y? Pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. So given this figure, the goal is to find the length of the segment x and this segment y. And to answer this, we will use some concept. And one of this is this concept. Since we know that the radius of the semicircle is 6, so we can say that this segment is 6 and the other segment is also equal to 6. Now, if we drop a perpendicular line in this position, we can say that the total length of the segment simply equal to 6 plus 6 or simply equal to 12 units. Now, let's focus on this right triangle. Now, this is a famous right triangle because the hypotenuse is 13, one leg is 12, so the other leg simply equal to 5. So this is the famous 5, 12, 13 right triangle. And this tells us that when we have x, the total segment, minus the segment y, we have equivalent to 5. So one equation is formed using this concept. So x minus y equals 5. Alright, now going back to our figure, we have now one equation involving x and y. Since we have two unknown variables, we need two equations. Now, to have another equation, we need this point, the point of tangency, because this is very important. Because using this concept, if we have two tangent lines that is connected to an external point, it says that these two tangent lines are said to be equal. So this is not hard to prove. And again, we will use this concept to answer this question. Now, notice these two tangent lines. This segment is x, so the other segment is also x, using this concept. And now, on the other side, this tangent segment y, and this is also a tangent segment. We have a common point right over here, therefore this segment is also equal to y. And we can create, again, an equation that consists of x and y, because if we add x and y, we get a total of 13. So x plus y equals 13. Now, using these two equations, we can now solve for the value of x and y. So technically, if we add these two equations, we eliminate negative y and positive y, because this is just 0. So 2x equals 5 plus 13, or simply equal to 18. Divide both sides by 2, we get x equals 9. If x is 9, 9 minus y equals 5, and 9 plus y equals 13. Therefore, y, we can say that y equals 4. And this is the value of x and y. So given this figure, then the value of segment x and the length of segment y simply equal to 9 and 4, respectively. And as always, we are done.